Imagine the following scenario. An individual tries to guess a password. Those repeated login attempts do need our attention in real time, but we also need to quickly gather intelligence to draw a clear, complete and contextualized picture. Now let's see how the QRadar 400 and QRadar combined solution can help you gain the needed visibility into what just happened.
Using an IBM Access for Windows session client, let's try and log in as QSecOffer. Please note that we are here using the highest administrator profile for IBM systems. So let's now try to guess the password. As soon as we press enter, we get a message which you can see at the bottom of the screen. The message clearly indicates that the password is incorrect for this user profile. Let's try yet another password. As soon as we press enter, we now get a new message which you can see at the bottom of the screen. The message clearly indicates that the next invalid sign-on attempt will vary off this device. Please note that it will also disable this user profile. As we do not want to lock this account and bring our activities to the security folks' attention, let's try another user. So let's try the user QSysOPR, which by the way, is not as powerful as the previous user. As soon as we press enter, we see that the device is switched off. Not a real problem. Let's use another tool such as a Windows Telnet client to log in as a well-known HA product such as Mimix. As soon as we press enter, we clearly see that the user does not exist. Again, not a real problem. Let's now try a well-known IBM user such as IBM SPT. As soon as we press enter, we see a message that clearly indicates that the next invalid sign-on attempt will vary off this session. Again, not a real problem. Let's now try the root user. Upon pressing enter, we see that the session was disabled because of the multiple failed sign-on attempts. Now let's turn to QRadar to demonstrate how we would know about those login attempts. We will also use QRadar to gather intelligence and to draw a clear, complete and contextualized picture. Out of the box, QRadar comes with the following simple rule that detects multiple login failures for a single username within a time frame. This rule ensures that those detected failed logins are part of an offense, as shown on the screen. We should therefore see several offenses. One for each of the user profiles used by this user while trying to guess the password. At this point, you should also notice that in the case where the malicious user eventually guesses the password, the following rule should trigger. This rule also ensures that the detected events are part of an offense as shown on the screen, resulting in an offense update associated with a particular user profile. Let's now dive into the Cilasoft events. The Cilasoft events report on activities carried out by users who connect to the IBM from a workstation. But the questions are as follows. Who are the individuals behind those activities? Who is behind the keyboard? How can we retrieve additional context from QRadar? Let's carefully consider and reflect upon the following advanced search. Please note that this advanced search performs two AQL data retrieval functions. The asset property function is used to perform a lookup on a specific property for an asset. The asset user function searches for the user of an asset at a point in time. In this example, at the time of the query which is set to now. This function returns the username that is affiliated with the source IP address. Let's now run this search and look at the results. As you can see on the screen, the user GM is affiliated with the asset 192.168.5.201, that is the same source IP address picked up by the previously mentioned offenses. Please note that the asset user information is retrieved from the asset database which is managed and automatically updated by QRadar. In order to maintain the asset data captured in the asset database, QRadar uses information such as network flows, scanner data, and login events. In this video, we cannot possibly demonstrate the many powerful possibilities offered by those advanced searches. The aerial query language we used in the previously demonstrated advanced search is a structured language we can use to query and manipulate event and flow data from QRadar's aerial database.